Hi subscribers, welcome to our channel. This is Kishore Palwarsa. Please subscribe our channel for more videos as well as for more information for the new concept oriented classes, as well as I need your support. Okay, as well as if anyone is not subscribed till now, please subscribe now, as well as please click on the bell icon. Please click on the bell icon. Okay, please don't forget. So now today we are going to discussing about different types of EMFs in both machines as well as transformers. Okay, both machines as well as transformers. Okay, so note, so coming to the EMFs in that both machines means either generators or else also called as motors, as well as in transformers there are producing of according to that nature there are two types of EMFs will be there. There are two types of EMFs will be there. Okay, one is the dynamically induced EMF, one is the, which is very important. Okay, one is the dynamically induced EMF. Okay, and second one is the statically induced EMF, and second one is the statically induced EMF. Okay, one is the dynamically induced EMF and second one is the statically induced EMF. So these different types of EMFs will be existing in both DC machines as well as transformers. Okay, so DC machines means either we have to take the example for either generators or motor, DC generators or motors. Okay, so coming to the statically induced EMF, let us best example for the transformer. How can we justify all those the type of machines? We can now clarify now. Okay, we can clarify now. So coming to the dynamically induced EMF, okay, let us consider like a DC generator. Okay, this is the generator. Let us consider this is like a DC generator, for example. Okay, so in the generator basically, okay, the conductor is rotating. Here the conductor is rotating, flux is stationary. Already know that flux is stationary as well as conductor is rotating. Okay, so let us consider, so this generator can be quite represented. Already know that in the previous sessions already we are discussing the so total entire working principle and also so EMF equations of generators individually. So if you have any doubt, please go through once, see the all different types of classes. Okay, so let us consider, okay, this is the so this is the north pole as well as this is the south pole. This is the stator. Okay, this is the rotor. Okay, the here the flux which is always flows from north pole to south pole, like this. Okay, north pole to south pole like this. Okay, here flux will be always flow from north pole to south pole. Okay, so coming from here, okay, so here dynamically induced EMF, coming to the here the rotor will be rotating. Here rotor means conductor. Here the conductor is rotating, flux is stationary. Here the flux is stationary means here the flux which is always flows from north to south. Okay, north to south. That's why simply we have to here the just identified as like a flux is stationary. Simply judged as a flux is stationary. Okay, conductor is rotating, always rotating, flux is stationary. Okay, that's why in that produced EMF is dynamically induced EMF. Why? Because rotor is rotating, conductor is rotating. So that's why in that DC generator or like a motors, any machines generally produced as a basically dynamically induced EMF. Dynamically means like a moving. Whenever the conductor is moving, in that some flux will be existing. At that condition, simply we can judge it as a dynamically induced EMF. Okay, I think you have understood what I am saying. So coming to the statically induced EMF, we have to take into the best example of like a transformer. Okay, so this is the transformer. Okay, so in the transformer basically statically induced EMF will be existing. How it will be existing? Okay, so whenever electrical supply is given to here, given to the transformer, in this transformer there is no moving of any type of parts. Here there is no moving, both primary winding as well as secondary winding. So here all windings may be contains to the standstill position. Standstill are like some stationary position. Okay, or some fixed position. Here there is no moving of parts. So when compared to the generator, so in the generator may be contains rotor will be rotating. So means it is moving part. So that's why in that produces a dynamical induced EMF. So coming to the transformer, in the transformer there is no moving of any type of parts. That's why in that produced EMF is called as statically induced EMF. Okay, so please remember that, very important. So coming to the this statically induced EMF, okay, so there are basically two types in the statically induced EMF. Okay, one is the self-induced EMF, one is the self-induced EMF. Okay, self-induced EMF, and second one is the mutually induced EMF. And second one is the mutually induced EMF. Okay, which is, those are the very important. One is the self-induced EMF and second one is the mutually induced EMF. Okay, so according to the flux existing in that particular both primary winding as well as secondary winding nature, they can be classified into two types. One is the self-induced EMF and second one is the mutually induced EMF. Okay, so let us coming for the self-induced EMF here. Okay, so simply we can say that the self-induced EMF, okay, here when we are supply is given to the primary winding of the transformer, here supply means like a AC supply. Let us for single phase, simply we can call it as like a either 220 or like a 230 volts, either 220 or like a 230 volts. Okay, when our supply is given to the transformer, then some flux will be existing in that primary winding. Okay, then some flux will be existing in that primary winding. Okay, so simply we can call that the self-induced EMF. So whenever supply is given to the primary winding of the transformer, then itself produced flux, then itself produced EMF, then itself produced then itself created own flux, then itself produced created own flux. That is called as self-induced EMF. Okay, I think you are understood what I am saying. సో ఎప్పుడైతే మనం ప్రైమరీ వైండింగ్ సప్లై ఇస్తానో, సో సప్లై ఇచ్చినప్పుడు ఆ ప్రైమరీ వైండింగ్ ఏమవుతుంది, మనకి ఆటోమేటిక్ ఫ్లక్స్ క్రియేట్ అవుతుంది. దానికి ఓన్గా క్రియేట్ అయింది, ఫ్లక్స్ క్రియేట్ చేసుకుంటే దాన్ని ఏమంటాం మనం సెల్ఫ్ ఇండ్యూస్డ్ ఈఎంఎఫ్ అని అంటాం. ఓకే, సెల్ఫ్ ఇండ్యూస్డ్ ఈఎంఎఫ్ అని అంటాం. సో let us go for the mutually induced EMF. Okay, here mutual means so between any, which is basically communication between one to another, basically you can say that one to another. Okay, so let us coming for the here also. Okay, here mutual induced EMF means whenever supply is given to the primary winding of the transformer. Okay, in that primary winding of the transformer some flux will be existing. Okay, this flux will be so cuts to the another winding of the transformer, another winding of the secondary winding, then only it is called as mutually induced EMF. Mutual means between the flux which is cuts are linkaging between two windings, both primary winding as well as secondary winding of the transformer. That is called as mutually induced EMF. Okay, so primary winding some flux will be existing. Okay, this flux will be so here not constant, still to fixed position. This flux is again which is cuts to the secondary winding of the transformer through the media of air. Okay, why? Because here there is no electrical connection between both primary and secondary. Okay, both only magnetically coupled between those two. Magnetical means either like a mechanically coupled between those two. So there is no electrical connection between primary and secondary. That's why here only the flux which is cuts through with the help of media of air from primary winding to secondary winding, and also in the secondary winding also some EMF will be existing. Due to the EMF resultant some voltage resultant, finally we can get to the currents also. That current will be given to the load center. Okay, so this is the different types of process. Simply you can say that coming to the mutually, the flux which is cuts from one winding to another winding, that is called as mutually induced EMF. Okay, so this is the today our class subscribers. Okay, if anyone is till now not subscribed our channel, please subscribe now. Okay, as well as please encourage to me, as well as for more new concepts please go through visit daily our channel. Don't forget, as well as please click on the bell icon. Okay, so please share and as well as please support to me. Thank you one and all. Thank you.